We can now understand resistance not just as a philosophical or spiritual concept, but as a neurobiological phenomenon with clear scientific foundations. Modern neuroscience offers us extraordinary insights into how and why this force operates within our brain. When Stephen Pressfield described resistance as an invisible force working against our growth, he was inadvertently describing real neurological processes occurring inside your brain at this very moment. Let's explore what happens in neural circuits when resistance emerges and, more importantly, how we can use this knowledge to reprogram our brain. If this new understanding of resistance is transforming how you view your own behaviors, imagine the impact our upcoming videos will have on your life. Subscribe now to follow this journey of neuroscience-based self-discovery. To understand resistance, we first need to comprehend that our brain evolved primarily as a survival mechanism, not as a personal growth or creativity machine. For millions of years, our ancestors lived in environments where conserving energy and avoiding risks was essential for survival. A brain that wasted energy or took unnecessary risks was less likely to pass its genes forward. As a result, your brain is programmed to conserve energy whenever possible, avoid uncertainties in new situations, prefer short-term comfort over long-term benefits, and maintain predictable mental and behavioral states. These neurobiological tendencies aren't defects. They're sophisticated adaptations that ensured our survival as a species. The problem is that the world has changed drastically, but our brain still operates with the same basic hardware as our hunter-gatherer ancestors. When you feel resistance to starting that important project, it's not weakness of character. It's your ancestral brain doing exactly what it was programmed to do: conserve resources and avoid potentially risky situations. At the center of resistance's neurobiology is a small almond-shaped structure called the amygdala. Located deep in the brain, the amygdala functions as an alarm system that detects potential threats. What you need to understand is that for your amygdala, a new creative idea, a challenging project, or a major life change are processed similarly to physical threats. This happens because any situation involving uncertainty or potential for failure is interpreted as potentially dangerous. When you decide to start writing that book, launch that business, or make that important change, your amygdala fires, initiating the famous fight or flight response. Your heart rate increases, your breathing becomes faster and shallower, stress hormones like cortisol and adrenaline are released, and blood is directed to the muscles and diverted from the prefrontal cortex. This last effect is particularly important. Under stress, the brain literally reduces blood flow to the areas responsible for creative thinking and long-term planning. That's why, under the influence of resistance, you may feel mentally foggy or unable to clearly visualize the next steps. Neuroimaging studies show that when people face anxiety-provoking tasks, activity in the amygdala increases while activity in the prefrontal cortex decreases. This is the neural pattern of resistance in action. Another essential component of resistance's neurobiology is the brain's reward system, mediated by the neurotransmitter dopamine. Dopamine is not, as many think, simply the pleasure hormone. Its primary function is to motivate goal-oriented behaviors and signal reward expectation. It's essentially the system that says this is worth doing. Here's the problem. Your dopaminergic system evolved to value immediate, concrete, and guaranteed rewards over distant, abstract, and uncertain rewards. Checking social media releases a small but immediate dose of dopamine. Working on a long-term project, on the other hand, offers little or no immediate dopaminergic reward. This explains why resistance often manifests as procrastination through distractions. Your brain is literally addicted to the small doses of dopamine provided by activities that offer instant gratification. Neuroimaging reveals that when someone receives a notification on their smartphone, the same brain regions activate as when a gambler wins at a casino. This is a powerful neurological force working against your long-term goals. If the amygdala and reward circuits are the generators of resistance, the prefrontal cortex is our main ally in overcoming it. This region, located just behind the forehead, is responsible for executive functions such as long-term planning, impulse inhibition, attentional focus, value-based decision-making, and emotional regulation. The prefrontal cortex is what separates us from other animals. It's the CEO of the brain. But here's the challenge. This region is metabolically expensive. It uses more energy than most other parts of the brain and tires easily. Research demonstrates that the prefrontal cortex suffers from decision fatigue. Each decision we make throughout the day gradually depletes our reserve of mental energy, making us increasingly susceptible to resistance as the day progresses. That's why we often feel less resistance in the morning, after a good night's sleep that has recharged our prefrontal cortex, and more resistance at night, when this area is already exhausted. Neuroimaging studies confirm people who consistently overcome procrastination show greater activity and connectivity in the prefrontal cortex. They don't necessarily feel less resistance. Their brain is simply more effective at overcoming it. The most revolutionary news from modern neuroscience is the discovery of neuroplasticity, the brain's ability to reorganize itself and form new connections throughout life. This means that, although your brain may currently be hardwired for resistance, it can be literally reprogrammed through consistent practices. Each time you give in to procrastination, you reinforce the neural circuits of resistance, making it stronger the next time. But the reverse is also true. Each time you overcome resistance, you strengthen alternative neural circuits that facilitate future action. Neuroplasticity explains why the first week of a new habit is so difficult, but the fourth week is significantly easier. You are literally creating new neural highways that bypass the resistance circuits. Studies with experienced meditators show structural changes in brain regions associated with self-control and emotional regulation. Their amygdalas are less reactive to stressors, and their prefrontal cortex shows greater thickness and connectivity. In other words, practices like mindfulness meditation, especially when maintained for extended periods, literally rebuild the brain to be less susceptible to resistance. The flow states described by psychologist Mihaly Csikszentmihalyi represent the neurological opposite of resistance. During these states of total immersion and high performance, we observe a fascinating brain pattern. The amygdala's activity decreases significantly, the prefrontal cortex reduces activity in certain areas, particularly those linked to self-criticism. Brain waves shift to an alpha-theta pattern at the boundary between wakefulness and sleep, and there is an increase in neural synchronization between different brain regions. Neurochemically, the flow state creates a totally different experience from resistance. While in flow, your brain produces a powerful mix of substances. Dopamine flows abundantly, increasing your motivation and sense of reward. Serotonin rises, promoting well-being and satisfaction. If your activity involves other people, oxytocin comes into play, strengthening social connections. And endorphins, our natural opioids, generate pleasure and decrease any discomfort. This biochemical symphony creates an experience that is the exact opposite of resistance. Instead of internal struggle, you experience fluency. Instead of self-criticism, there is total immersion. The paradox is that to access this ideal neurological state, we first need to overcome the initial resistance. Flow typically appears after the first 10-15 minutes of consistent engagement, exactly the period when resistance is strongest. Now that we understand the neurobiological basis of resistance, we can develop targeted strategies to reprogram the brain. Start by leveraging the power of morning routines. In the morning, your prefrontal cortex is at its strongest, freshly recharged by sleep. Studies show that decisions made in the early hours are more likely to align with long-term goals. It's the perfect time to face tasks that would normally provoke strong resistance. Use the power of microtasks. Your brain processes a small task differently than a large one. When you face a small step, the amygdala remains relatively calm. However, when contemplating an entire project, it triggers alarm signals. Neuroimaging confirms this. Breaking projects into steps so small that they don't trigger the stress response makes all the difference. Mindfulness meditation is not just a passing trend. It's a brain restructuring tool. Regular practice increases the cortical thickness of the prefrontal cortex and reduces amygdala reactivity. Just 8 weeks of daily practice for 10 to 20 minutes produces measurable changes in brain structure that facilitate overcoming resistance. Don't underestimate the power of regular physical exercise. Beyond the obvious benefits for the body, exercise increases BDNF, a protein often called brain fertilizer, which promotes the growth of new neurons and connections. This drastically improves brain plasticity, facilitating the formation of new habits and overcoming old patterns of resistance. Take advantage of the implementation intention technique, creating if-then plans. When you pre-program responses for specific situations, if it's 9 a.m., then I'll sit down to write for 30 minutes. You preemptively activate the prefrontal cortex before resistance can emerge. It's like putting your brain on autopilot for success. Establish consistent rituals for your most important activities. When an action becomes ritual, it transfers control from the prefrontal cortex, which requires conscious effort, to the basal ganglia, brain structures associated with automatic behaviors. These require less energy and are much less susceptible to resistance. That's why successful writers often have fixed times for writing. They're not relying on willpower, but on efficient neurology. Finally, practice gradual exposure to discomfort. Systematic exposure to small doses of discomfort desensitizes the amygdala over time. This is the same neurological principle that allows overcoming phobias, adapted to defeating resistance. Start with brief periods of discomfort, gradually increasing as your brain adapts. Resistance doesn't operate only at the neural level, but also in the endocrine system, our hormones. When we face resistance, our body often releases cortisol, the stress hormone, which in the long term has harmful effects on both physical health and cognition. Chronically elevated cortisol is associated with decreased hippocampal volume, the crucial brain region for learning and memory. On the other hand, when we overcome resistance and engage in meaningful activities, we experience a completely different hormonal profile. Dopamine begins to flow, bringing sensations of motivation and satisfaction with each small progress we make. Serotonin rises, creating an overall sense of well-being and peace. If our work involves other people, oxytocin, often called the bonding hormone, strengthens our social connections. And endorphins, our natural opioids, produce a gentle feeling of pleasure while reducing any discomfort we might feel during the effort. This positive hormonal profile not only produces momentary well-being, but also strengthens the neural connections that will facilitate future efforts against resistance. It's a virtuous biochemical cycle. One of the most important contributions of neuroscience to our understanding of resistance is the liberation from guilt and shame. When we understand that procrastination, fear, and doubt have concrete neurobiological bases, that they are literally brain circuits doing exactly what they were evolutionarily programmed to do, we can stop blaming ourselves for experiencing them. You're not fighting against a character flaw, but against ancient brain systems that can be reprogrammed through consistent practices. This understanding by itself already begins to neutralize the power of resistance. Guilt and shame, ironically, activate the amygdala even more, creating a neurological vicious cycle. By adopting a stance of scientific curiosity about your own resistance patterns, you're already interrupting this cycle. The neuroscience of resistance shows us something extraordinary. Your brain is not your enemy, it's just operating with old programming that can be updated. Each consistent practice against resistance not only produces the immediate result of that specific action, but also gradually reconfigures your brain to be less susceptible to resistance in the future. The beauty of neuroplasticity is that it operates in both directions. Just as your brain can be conditioned for resistance, it can also be reconditioned for action, purpose, and flow. This explains why people who consistently overcome resistance in one area of life often develop greater capacity to overcome it in other areas. The neural changes are transferable. The next time you feel resistance arising, remember, you are witnessing an ancient neurological program in action. It's not the truth about you or your potential. It's simply your brain doing what it was programmed to do. And just as a programmer can rewrite code, you can reprogram these ancestral circuits through deliberate and consistent practices. Not by eliminating resistance, but by transcending it through understanding and application of neuroscience. In the next chapter, we'll translate this knowledge into practical strategies that you can implement today to begin reprogramming your brain for success. If this video is expanding your understanding of your own mental patterns, share it with someone who could benefit from this knowledge. The neuroscience of resistance is especially powerful because it demystifies behaviors that many people mistakenly interpret as character flaws. And if you haven't subscribed to the channel yet, this is the perfect time to continue this journey of science-based self-knowledge. See you in the next video.